How can we really tell that climate change is happening? Do we have proofs? Well, yes. Glacial retreat, global temperature rise, sea level rise, extreme events, ocean acidification, and the increase of carbon dioxide. The planet's average surface temperature has risen about zero point 0.9 degrees Celsius since the late 19th century, a change driven largely by increased carbon dioxide and other human-made emissions into the atmosphere. Most of the warming occurred in the past 35 years, with the 5 warmest years on record taking place since 2010, with 2016 as the warmest. Have you seen in the news and the internet? Ice, which covers 10% of the Earth's surface, is disappearing rapidly. Data from NASA's Gravity Recovery and Climate Experiment satellites or GRACE show that the land ice sheets in both Antarctica and Greenland have been losing mass since 2002. Both ice sheets have seen an acceleration of ice mass loss since 2009. The rate of Antarctica ice mass loss has tripled in the last decade. Illulisat Glacier, June 2007 to June 2009. The Illulisat Glacier deposits more icebergs, 35 to 50 cubic kilometers per year, into the ocean than any other glacier in the northern hemisphere, and is thus Greenland's single largest contributor to global sea level rise. The iceberg that sank Titanic probably originated here, while in Arctic, 12.8% per decade is the approximate decrease in annual Arctic minimum area. We've mentioned about the sea level rise a while ago, and it's one of the proofs of climate change. The global sea rose about 8 inches in the last century. The rate in the last 2 decades doubled through the last century. Sea level rise is caused primarily by 2 factors related to global warming: the added water from melting ice sheets and glaciers, and the expansion of seawater as it warms. The graph tracks the change in sea level since 1993 as observed by satellites. As temperatures rise, mass coral bleaching events and infectious disease outbreaks are becoming more frequent. Additionally, the ocean absorbs about a quarter of the carbon dioxide released into the atmosphere every year. So, as atmospheric CO2 levels increase, so do the levels in the ocean. Carbon dioxide absorbed into the ocean mixes with seawater to form carbonic acid, making the oceans more acidic with low pH level, which threatens the food supply and the economies of coastal communities. This process is called ocean acidification. As the world has warmed, that warming has triggered many other changes to the Earth's climate. Heat waves are periods of abnormally hot weather lasting days to weeks. Higher temperatures lead to increased rates of evaporation and drought, including more loss of moisture through plant leaves. An example of recent drought occurred in 2011. Map shows that many locations in Texas and Oklahoma experienced more than 100 days over 100 degrees Fahrenheit. That show the average summer temperature and total rainfall in Texas for each year from 1895 to 2012. Lastly, the most important proof, the increase of carbon dioxide. Carbon dioxide or CO2 is an important heat-trapping greenhouse gas which is released through human activities such as deforestation and burning fossil fuels, as well as natural processes such as respiration and volcanic eruptions. The first graph shows atmospheric carbon dioxide levels measured at Mauna Loa Observatory, Hawaii, in recent years, with average seasonal cycle removed. As discussed, carbon dioxide is one of the greenhouse gases. The greenhouse gases help in balancing Earth's temperature, not too cold and not too warm. But it all changed when Industrial Revolution came during the 1800s. The world saw a major increase in population, which along with an increase in living standards led to the depletion of natural resources. The use of chemicals and fuel in factories resulted in increased air and water pollution and an increased use of fossil fuels.